Miss Wenqiao Wang, she is also from the Department of Forestry of National Zhongxing University. The topic here is going to present the decision tree coupled with the discriminant analysis to predict species spatial distribution of a Piranha insignis. Okay, so you change your topic slightly. Okay, that's fine.
Good afternoon, ladies and gentlemen. Thank you for your interest in my presentation. I am Wenqiao Wang, a graduate student from Zhongxing University in Taichung, Taiwan. And my subject of my presentation today is coupling multivariate statistical method for two-round species distribution model. This is our outline. First is introduction. Biodiversity is very important for human and all other species on Earth. Without the diversity of species, ecosystems are more vulnerable to natural disaster and climate change. And species distribution model SDN is an increasingly important tool, and it can apply to conservation and protection, rare species, ecology, epidemiology, and disaster and management in forest. And there are many reasons to employ SDN. The most one is data quality. And model prediction quality based on data quality, and that species assigned should be as reliable as species present. But absent data are usually difficult to obtain and had not been recorded in past. And modeling rare species with pseudo-absent may be appropriate because rare species distribution are narrower than that of widespread species. Those sample selection by background has highly property to be absent. We use two methods to obtain background sample to investigate the effect of background sample on SDN. So our object is use DTLMR and DA to building SDN model for predict the potential habitat of a rare plant species in the Huishan study area. And run the three SDN model on an interval base by incorporation, elevation, slope, aspect, terrain position, and the vegetation in the first two rounds. And we selection background sample have two ways. First one is adapted to background sample, randomly take from the study area for building solo DT and solo LMR. And second one, take background sample randomly from the not target species area, predict by DA, and use them to building DTDA and LRDA couple model. And compare the predictive accuracy of each couple model and its complete spanned solo model to evaluate the model couple effects on the performance of each couple model. And the next is our study area target. And we choose the Huishan Forest. It's local in central Taiwan, which is property of Zhongxing University. we choose the start area with rectangular strip, which encompasses the Huishan Force Station, and has total area of 17,136 hectares. And this is Huishan Forest. And our target site is only found in mountains of central Taiwan, and such as the Huishan Forest Station and the Dongmao Mountain area. And the Huishan is the main habitat of the species. And cyclone found in area with sufficient sunshine and well-drained soil. And our field survey data is cyclone samples were acquired by using GPS link with a laser range. The area was usually below 1 meter, and total number of the cyclone samples collected by 松峰山杜鹃岭的关刀山 tile in Huishan was equal to 182. And the number of background samples randomly taken from the entire study area was about 4 times more than that of target sample. And these are the 松峰山杜鹃岭的关刀山 tile. And material and the method. And so we collect the automated map and the DM and the satellite image. So gradient is the elevation, slope, aspect, internal precision, and the vegetation indeed. And then we overlay the cyclone on those layers and analyze the species distribution of cyclone in GIS. And then we use 3 methods. So we simply introduction the method. And first one is DT. DT is constructed by repeatedly spell the data and defined by a simple rule based on a single exploration variable and decision pathway arrangement from the rules that contain all caps, and the ending method node contain the output subset of case. And terminal nodes are assigned a final outcome based on the good membership of the majority of case. And the LL model can be expressed as follows. And the output property values range from 0 to 1, and 1 indicates the 0% property of the target habitat, and 1 indicates 100% property. And first, finally is DA. DA is performed by doing the following: finding linear compounds of n and independent of independent variable, and test if the costs centrally are different, and determine which variable contributions significant, and assign unclassified ONE observation to one object class. And model validation. We took the spell sample validation approach for model validation. 2/3 of data set for model derivation, 1/3 of data set for model validation, and to assign classified accuracy including producer accuracy, user accuracy, overall accuracy, and the kappa coefficient. And next is result discussion. And first we see the accuracy of the soil model for particular location habitat of the cyclone. And you can see the DT is the best. The kappa value is 0.96 in test case, and the second one is LMR. The kappa value is 0.85 in test case, and the DA was the worst. And this is because the commission error of DA is 35%. This is because DT DA classify more background pixel to the circumference pixel, so the commission error is greater than LMR and DT. Next, we see the predictive model graded by the 3 methods. We can see DT also reduced suffer less than 2% of the total area, and the LMR was the second, is 5% of the total area, and DA was the worst, is the 22%. So we can see this one is DT predictive model, and in large part we can see this one is this is background sample is predict correct, and the background also predict correct, and this one is LNR predict model, and also in large part we can see the target sample. It's some omission, and the background sample is more commission than DT. This one and this one, and this one is DS predict map. So we can clearly see the target sample is correct, but the background sample is more commission error than LMI and DT. So we choose the potential capture gradient from the DA to match as match to the background sample. Take background sample from the not circumference area here. So when compare between the accuracy of solo model and the couple model. So in DT model, the overall accuracy increased the 1% in training case and test case, and kappa value also increased in 0.04 and 0.03. And in LMR model also increased in 6% and 4% in test and training and test case, and also kappa value increased. And then we can see the LMR couple model is the result is similar to DT model. So our conclusion: the three model that relate the no circumference size to habitat characteristics and predict the circumference potential C in the study area. And DT and MR substantially reduce the area of well survived to less than 5% of the Huisun study area, and were implement and potential. And both DT and the LR couple model improve model performance as their background sample suggest from not habitat of prediction model could more reliable for model prediction. And LMR couple model improve performance greater than DT couple model. And more importantly, they can parallelize either the well survived area, where is it able to collect fine spatial resolution microclimate and vector and all biotic data for refining prediction of condition habitat in the later round of SDN. And search area for new population discover under condition of limited funding and manpower. And further up, that it will attend to incorporation proxy integration that can be extra from hyperspectral image or LFL or LiDAR DN, and the subset of the vector parameter, and so that predict model are alpha couple on broad scale. This is my presentation. Thank you for attention.
For Ms. Wang's presentation. So now we have time for question and comment.
You targeted a kind of ferret. Why did you choose the species of the ferret?
The cyclone is very rare in Taiwan. It's very limited in central Taiwan. It's only found in Huizun and the Dongnao Mountain, and not found in other places. So we chose it target to look if could find maybe it can burn in the outside, or we not know
yet. Does your presentation have any relation to the previous presentation by previous speaker? Who was that? Dr. Chun How to?
Yes.
Yeah, the target region is the same.
Yes.
And so do you collaborate with him?
Classmate. Yes.
Oh, classmate.
So you study on the same area but using different approach.
Yes.
So who is better?
Maybe it's later.
Okay. So we still have time for questions and comments. So if there's no more question or comment, and we are going to close the session. So let's thank again for all the presenters in this session for their contributions. Thank you.
Thanks for chairs, the Dr. Suzuki and Dr. Zhang, and all presenters. Now it's about 3:30. It's tea break time. The conference to prepare some desserts, coffee, and tea outside the room. Enjoy your afternoon.